calculation all about. We'll be using ChemSketch to do that. ChemDraw cannot calculate your reaction, but ChemSketch can do that perfectly. Let me explain what we really mean by the reaction calculation. Now, if you are doing synthesis, let's say you want to synthesize anthraquinone. Maybe your synthesis is to synthesize anthraquinone. And anthraquinone can be a single step reaction. It can also be a multiple step reaction. But let's work with the one we have already done. From this place we have anthraquinone. Who is disturbing my class now? Okay, I think I've added everybody. All right, let's continue. All right, can you see my screen?
Yes, sir.
Okay. Now, from my screen, let's assume that this is the synthesis we want to do, and this man is our target. Let's say we want to synthesize anthracene 910-dione, and this anthracene 910-dione is new, and you begin to ask yourself some questions. What are the reagents? What are the starting materials I will use? If you have been able to identify the starting materials, like here, we are starting with phthalate anhydride with benzene. But it is not a one-step reaction, because the first reaction will lead to benzoic acid. Then the benzoic acid will further undergo dehydration reaction with sulfuric acid to give us the anthracene 910-dione. So this is a, let me call it, is a two-step reaction. Now, you begin to ask yourself, what amount of the product do I need? What amount of the product do I need? And maybe in your synthesis, you want to at least synthesize of like 10 gram of the products. Maybe that is your target. You want to synthesize 10 gram of the product. You then begin to ask yourself, what amount of the reactants am I going to use? Since my target is to synthesize up to 10 gram of anthracene 910-dione, what amount of phthalate anhydride am I going to use? And what amount of benzene am I also going to use to proceed the reaction, so that at the end I will achieve up to 10 gram of anthracene 910-dione. Those who are good with chemistry will say, okay, let's start calculating the limiting reagent and the SS reagent. No be so? Am I right?
Yeah.
So we say, okay, let's start calculating the limiting reagent and the SS reagent. You don't need all those stuff again. What you just need to do is, since this reaction is two-step reaction, start with the last one. Start with the last stage to calculate your yield. Or to calculate the amount of the reactant with an expected yield, whichever case. But the best one is calculating the amount of the reactant to be used with an expected yield, which we call the true yield. So start from the last stream, the last reaction, we may have up to like five different reactions here, but I'll start with the very last one. So this is the last reaction that led to my anthracene 910-dione. You will now ask yourself, if I'm targeting 10 grams of this my product, what mass of benzoic acid can generate that 10 gram? Maybe we may have that 5 gram of benzoic acid will produce the 10 gram. Then you now go back again. Since I will need 5 gram of benzoic acid, what mass, what quantity of phthalate anhydride and what quantity of benzene will I react that will give me the 5 gram of benzoic acid, which will further proceed the second reaction to produce the 10 gram of anthracene 910-dione. So this is what will be in your mind. But we are going to be doing all this calculation using ChemSketch. So we will not be cracking your brain, trying to stress yourself in doing no manner of calculation. See what you just do. Highlight the last equation. How I wish you can do this with me. Highlight the last equation. Remember our workflow. I've explained the workflow. The workflow is start down, assume an expected yield of your product, then from the last equation, what quantity of the intermediate will produce that expected mass of the product, then from the intermediate again, what quantity of the reactant will give me the calculated mass of my intermediates, which will further lead to my final product. So what you just do is highlight the last reaction, this last one, highlight it, then come up. You see this place? What is it called? If you have seen my screen, I don't know if you can see it.
Reaction calculator.
Good. I will click on the reaction calculator. Once you click on it, don't bother yourself. Take your cursor to your reaction arrow. This thing is calculating. Once you have drawn your reaction scheme, it will store the reactant and the product. It will store it. It will even tell us it will even tell you if the equation is if probably the equation you wrote should be right or wrong. It will probably try to explain that to you. Now, so once you have clicked on reaction calculator, quickly take your cursor to that reaction arrow. It will show you the icon of the reaction calculator. Then click on that reaction arrow. Once you click on the reaction arrow, the platform for reaction calculator will appear. It will understand that there is one reactant and one product. So at the reactant part, I'm seeing one reactant. At the product part, I'm seeing one product. Then theory 1. This theory is the same with your product. Now the theory is the theoretical yield in theory. We don't have business with the product. We will not alter anything in the product because it does not make sense. We will be altering our theoretical yield. You then ask yourself, since my product, because the product and the theory are the same thing, so at the theoretical yield, K is mole ratio, N is molarity, C is concentration, M is mass, V is volume, D is density, and your yield. So remember, we are saying let's use 10 gram as my theoretical yield. So once I come to my mass, under the theory, this place come to mass. Once I click on the mouse, type 10. I need 10 grams and click outside. It will automatically do a calculation for you that if you want to achieve 10 gram and the yield is showing 100%, which I want 100% of 10 gram of my product, the reactant, which is, we have just one reactant, that 10.865 gram of 2-benzoic acid is what is required to produce 10 gram of my anthracene 9,10-dione. I don't know if you are following up. At this point, I will love you to interact with me. Do you understand that?
Go ahead, sir.
Okay. So the reaction calculator have just calculated that for me to achieve this 10 gram, it even went for it to calculate the mole, that 10 gram of anthracene 9,10-dione is 0.048 mole based on the formula weight. So that if we must achieve this 10 gram being 100% the yield, that we require 10.85 gram of the reactant, which is benzoic acid. So, but remember that this benzoic acid is not your starting reagent, it's an intermediate. So you are going to take note of that mass, copy it somewhere, 10.865 grams. Then your next question will be, since I need 10.865 gram of 2-benzoic acid to react with sulfuric acid to give me my target product, what quantity of the phthalate anhydride and benzene, what quantity of phthalate anhydride and benzene do I need to achieve that 10.865 gram? So we'll go back, we can close this. You then come to this other part, you come to this part, you highlight this. Now, what is our job now at this part? Our job is, we have calculated that we need 10.865 gram of benzoic acid. We now want to know what quantity of phthalate anhydride and benzene can give me that 10.865 gram. You go back to your reaction calculator, click on it, come to the arrow and click. Now, once you click there, what are you seeing at this point? If you can see the screen, what are you seeing at this point? How many reactants are you seeing there? How many reactants are you seeing on my table?
Two.
Good. I would like you to follow me so that I will know that you are following me. Because
2, sir.
So we are seeing 2 reactants. The first one is our phthalate anhydride, and the second one is our benzene. So now the product is our interest, which is our theoretical yield. So work with theory. Now, see what you will do. We have already gotten that we are now working with 10.865 gram of benzoic acid. So come to this mass, the mass of benzoic acid, and type your 10.865. Click outside. It will automatically calculate the mass of phthalate anhydride that you need and the mass of the benzene that you need. So here we are seeing that for me to achieve 100% of benzoic acid, which is 10.865 gram, I will have to weigh out 7.1135 gram of phthalate anhydride and react with 3.7515 gram of benzene. So invariably, for me to achieve 10 gram of anthraquinone, for me to achieve the final product, which is 10 gram of anthraquinone, I have been able to use my reaction calculator to know the amount of the starting reagent. So it is very easy and short for those of you who wishes to work on synthesis, that before you move into your synthesis, you first calculate. This stage is the fundamental stage before you jump into synthesis. You need to know the amount of the starting reagents, because if you are doing a publication, you are going to state it in your publication. At this point, let me attend to questions. Any question? I want to attend to your question. So do you have a question? Hello?
I think for now there's no question actually, sir.
Okay. That is for you. Does anybody have a question else to answer? If there's no question, you can just tell me to go ahead. Okay. It means we are actually following. Now, we have one pending problem. Let me ask the question now. Let me ask the question. Do you think with this we can jump to the lab? No. I want to ask a question. How can I measure 3.7515 gram of benzene? I'm using I have my weighing balance. How can I measure 3.7515 gram of benzene? Is the question now. Yeah, I'm asking the question. We are in the lab now. How will I measure 3.7515 gram of benzene?
I mean, I don't understand that, but is it not we use our balance or something to measure it?
I don't think so.
You cannot do that because it's not. I don't think benzene is a solid. So we have to do a little
Volumetric.
volume. So we have to do conversion from volume unit to mass volume unit. Sorry, mass volume unit to volume unit.
Okay. Okay, I think that is that's the correct answer. You have to convert that your mass, because benzene is liquid, but phthalate anhydride is solid, is a crystal. So for the phthalate anhydride, we can go straight, get the powder, get a weighing balance, weigh out 7.1135 gram and keep it. Then for our benzene is liquid. We cannot start pouring benzene in a beaker until our weighing balance gives us 3.7515 gram. That is the one approach. We are going to, since we have gotten the mass, we'll convert the mass to volume by using the equation for density. That density is mass over volume, which we can look for the density of benzene. But you see, all those calculations are a waste of time. We can easily do them with this reaction calculator. Yes, we can easily do them with our reaction calculator. See what we are going to do. Let me see if that will work. I want to actually quickly convert my mass to volume. You just need to supply the density of benzene. So let us see the density of benzene. Let us come back and look for the density of benzene is constant. You can Google it, or you click on benzene, you come to generate calculate properties. So we can just pick the density of benzene from here. The density of benzene is 0.873. So 0.873. So I will then come back to this my equation. So we are avoiding doing manual calculation. I will come back to this point and input what I've done before. For mass. This is 10.865. Then I will come to this density, type in the density of benzene 0.873. So once I type in that density of benzene 0.873, what did you notice? It has automatically calculated the volume I need. Are you seeing it?
Yeah.
Yes, sir.
Good. What is the volume there? What is the volume now?
4.2949.
All right. So you see that computational chemistry has made our work easier. What will be cracking our brain is start asking your colleague in the lab, I beg, remind me, what will be that formula of this thing? What is computational chemistry has developed softwares that will make our laboratory work easier and simpler for us. So with this, you just have to use your graduated measuring cylinder and measure accurately 4.2949 mil of benzene. Keep it aside. That means you have gotten your starting reagents. Good. All right. So I will pause a bit to see if there is also a question to ask. Any question?
Maybe not actually a question, but
Okay.
What if the other reactant, the first reactant,
Mm.
be uh, a solid? What if there is a need to make it a liquid? Maybe to dissolve it in a liquid. Maybe to calculate it in volume.
Okay.
I don't know if you understand what
Yes. Let
the
me.
mass. What if we need to convert it to volume? Is there a way of changing the volume, either through the density or from the mass already written here?
Okay. Let me. I think I have a clear picture of the question. I will answer it in 2 dimensions. Uh, Already benzene is liquid, and we know from fundamental chemistry about effect of the rate of chemical reaction, surface area, nature of reactants, all those stuffs. And liquid reagents in liquid states react faster than those in solid state. And now we have seen that phthalate anhydride is a solid. In the reaction, are we going to use it as a solid? Definitely we are going to dissolve it in water. So can this software tell us the volume it should be, the solution, the volume of the solution? I don't know if I'm coming to that angle now.
Yeah, you are there.
Yeah,
You are
all
there.
right. So since our phthalate anhydride is solid and we want to do the reaction, we must definitely have to dissolve it in water. So can we know the quantity of water that we are going to pour to dissolve it? Now see what we are going to do. We are going to calculate the concentration. We will calculate the concentration. That is what we will do. When we calculate, let's see, the software number one cannot literally tell you the exact volume to be used in the reaction. It's not telling you the exact volume to be used, but see what we're going to do. Let's try to supply a density here. Let's say the density, let me just assume, for instance, because I don't want to go back and start generating the density. Let me just say it is 0.911. Okay, it means it's not giving me what I want. I want to show you something else that could probably give us a clue of what you are asking. Let me say volume is 50 mil. Okay, it's not possible to do that. The ChemSketch cannot tell you the amount of water you are going to use to dissolve your phthalate anhydride. Yes, it cannot tell you the amount of water you're going to use, but when we start using the advanced software can actually tell you the concentrations of the solid reagents. But then what I will advise you to do is, since we have gotten the mass, that this is the mass we need, 7.1095 gram, that this is the mass we need, you can just decide to weigh out this mass and look out for any volume of your choice. Probably use 100 ml. Now, the reason why I said you can use any volume of your choice, probably are using 100 ml. The ChemSketch only understands the quantity of the reactant you are using. So you can decide to use 100 ml of water or 50 ml of water to dissolve the solid. The ChemSketch will not give account of the amount of liquid you are using, but it will not give you account of the quantity in mass of the reactant. So it assumes that the reaction will understand that what you are using is 7.1095 gram. But the best is using the advanced software that can actually also calculate the volume of water required. Because a student that dissolved 7 grams of the compound in 100 ml of water should not expect the same concentration with the student that dissolved 2 grams in the same 100 ml. So the concentrations will not be the same, because the amount of the solutes in that same 100 ml are no longer the same. So the molarity will differ. So but the ChemSketch is just giving you a clue of the mass you need to start the reagent. So it will not tell you the quantity of water you will need to dissolve the solid.
Okay, it's all right. That simply means that the software needs to be upgraded, because I think concentration has a lot to do when it comes to synthesis, because though I have not done synthesis before, but from my little knowledge, concentration can affect the reaction.
Yes, that is
I don't know if you corrected. So with this could be an impediment to this software, which I believe you have already mentioned it. You have other upgraded app, and I don't know. Assuming if I will be able to contact the builders of this app about this kind of a thing, this kind of upgrade. But that's fine. That's fine. Thank you very much.
okay. All right. Okay. Quickly, I want to show you some limitations. This reaction calculator cannot calculate for a multi-reaction at once. Let me assume we have this. I want to do this for you. Let's say this is what we have now. All right. So now look at what I did here. I was able to compress this 2 stage into one. I compressed them into one by saying phthalic anhydride react with benzene to produce benzoic acid. The benzoic acid further undergoes dehydration reaction to produce anthracene 910 diol. Now, if I don't want to stress myself to maybe let me just select all once, it will not work. I don't want to let you know, because some of us will be looking at for shortcuts. If I try to select all once, it will not work. If I go to reaction calculator, it will not work, because the reaction calculator we only click on one reaction arrow. So if I pick up this, it will only click on just one reaction arrow. So if I choose here, it will show me a reaction is drawn incorrectly or cannot be recognized. Even if I come to this point and click here, if I come to this point and click at this point, it will still write the same grammar, that it cannot understand the reaction here. Reason because it's not a single step reaction, so it cannot understand the reaction because it's not a single step reaction. So that means if you want to make use of it in your calculation, you simply need to break the reactions down stage by stage, just the way I have explained. Now, the last question I would like to share with you is this: can this reaction understand? Can it understand two products, two reactant, two products? The first instance we did, we had one reactant, one product, and the second instance we did, we had two reactants, one product. Now, what if I have a reaction that produced, that have two reactants and two products? Can this software interpret everything at once? Yes. In as much as it is a single stage, is a single step reaction, it will understand everything as a single step reaction. Where it will not interpret is when you are combining multiple step reactions at once. But once it's a single step reaction, it's going to understand it. Probably let me use a case study of, let's say we have benzene. And we want to react benzene with chlorine. We want to react benzene with chlorine. So benzene is reacting with chlorine, or better, let me say we want to react benzene with let's do Fidecraft alkylation. So let's pick one of these, and we want to react this I want to show this is chlorine. So if I have this and I am producing, I want to see if when I have two products with two reactants, will it be able to interpret for me? So it will produce, this will produce methylbenzene. This is methylbenzene plus HCl, so plus my HCl. Alright, of course this is a Fidecraft alkylation, so let me quickly write here. At the top I'm still using aluminum chloride as the reagent. So if I have such reaction like this, that in this case we are having two reactants and two products, can ChemSketch also understand the reaction and calculate for me? I will quickly highlight, let me quickly highlight it. Just select the reaction of your interest click on the reaction calculator, then come here and click. So once you click, it will tell you that you have two reactants and you have two products. So because it is a single step reaction, so it's a single step reaction, it will understand that you have two reactants and you have two products, and automatically it's going to calculate their formula mass. So which of them is your interest? Are you interested in the methylbenzene in toluene, or you are interested in the hydrochloric acid? Maybe your interest is on the toluene. You will just come to the toluene. What mass of the toluene do you need? Maybe I want to have 6.5 gram as my theoretical product. I will click outside. It will estimate everything, that for me to produce 6.5 gram of the toluene, that means it will also produce 2.5719 gram of my hydrogen chloride. Then the two reactants, I will need 5.5105 gram of benzene to react with 3.5614 gram of hydrochloric of methyl chloride. So it will automatically do that calculation, and you notice that it's not looking at your catalyst. The aluminum chloride is not affecting the reaction because it does not take part in the reaction. The job is just to alter the rate of the reaction. So you can do this if your reaction is producing multiple products using multiple reactants, in as much as it is a single step reaction, is going to understand it. Okay, so at this point, I think we have been able to conclude reaction scheme and reaction calculation. Is remaining reaction mechanism. So can we go ahead? Hello?
Sir?
What is the time? What is the time left for us?
What is the time?
How many minutes is left for us? Oh. If you have a question,
Time is not counting, no. Not see anything yet.
okay, we have 15 minutes. Oh, can we use 15 minutes for reaction mechanism? Okay.
Remaining 15 minutes.
I don't think we can use 15 minutes for reaction mechanism. Should I create another link and let's continue? Let's go for next 1 hour. I want to hear your response. Should we go for the next 1 hour? Let me give you another link to rejoin. Or we'll leave it for next class. Can you hear me? Can you hear me now?
We are still here.
So what I'm saying, we have about less than, we have 30 minutes, and 30 minutes will not take up reaction mechanism. I was asking, should we continue for the next 1 hour? So I will send you another link, or we say we have tried for the next day.
Maybe we'll leave it to next day.
I will leave it to.
Okay.
But,
I will give you an assignment now. The assignment is 10 marks. It will say this one way assignment, don't they carry mark now. Now screw it with it. I want to see your ability in chemistry. I will give you each of you, I will give you a target, a product. You are going to, on your own, develop the starting materials, develop the mechanism of the reaction, like develop the reactants and whatever they will be formed that will lead to that product. Is it possible? Can we try it? Like, for instance, I might give you ibuprofen. For instance, you have on your own, you study the reaction starting from benzene. I always love starting from benzene as a raw material. You develop the reaction scheme that will lead to the formation of ibuprofen. Then calculate the amount of the reactant that will give you like 5 grams of the product. Can we do that? I want to hear your response so I will know if you can do it or not.
I thought you said there is another software that will be able to break down a product and, tell the starting raw material for synthesis. You never mentioned that this software can do that.
Okay.
If I'm not.
I will call the name of the software. But before I call the name of the software, I want you all to crack your brain first. Use your brain and develop the starting raw materials. I will not give you compounds that are complex to synthesize. I will give you simple compounds that their synthesis is very easy. Because we are all chemists, although with different areas of chemistry, but at the end, all your various areas of chemistry boils down into synthesis, because that structure you are going to work with, at the end of everything, it will end up you synthesizing that compound. But we now leave it for those who are studying synthesis. There's no problem. But I will give you simple structures on your own. You can get them online. You can look for the reaction process starting from benzene that leads to those products. Then do everything we have done. Now, if you actually want to, if you don't want to stress your brain, you want to use that software. The software is ChemSketch. Let me type it. You can look for it online. This is the software. I'm typing it. All right. So, can you see it?
Hello.
Yeah, I have sent the software, the name, ChemSketch or ChemSketch. well, depending on how you call it. I just typed it and you can see it at the message. Just check the message box, you will see it. So this software is very, very good and versatile. If you have the money, you can buy it because you subscribe to it. I have it, I use it. You can have the money, you can buy it and practice for yourself because we need it. But meanwhile, can we do the assignments? Make I not waste my time giving assignments. Can we do it?
So give us. So you give us the assignment. We'll
Okay.
try our best.
I will give you. You just try your best.
I will
Yes.
give you. Try your best. Yes.
But I will give you
But I will give you
smaller
smaller
compounds that you can easily synthesize. All right.
Okay.
So
All right. So
we started late today. We started a bit late, and we're already ending by this time. So by Thursday, I will make sure I quickly round up the reaction mechanisms. By Thursday, we shall be looking at modeling and optimization. So we'll be introducing a new course by Thursday, and that new course will be modeling and optimization. So we can study more on that, modeling and optimization. We'll be using Chem 3D, ChemDraw and Chem 3D for that modeling and optimization. We'll model nanoparticles, we'll model novel compounds, we'll optimize them, we'll minimize their energy, and then we'll keep them as 3D form. All this while we have been keeping our structures in 2D, so we'll now keep them at 3D and see how we can use them in further studies. If we are able to finish the modeling and optimization, we will then move into another course, which is chemoinformatics. We'll move to chemoinformatics. We'll get to chemoinformatics. There we'll learn how to develop database. We'll have a major assignment. I'm planning of creating a group for us. I will form a group of 2 persons per group. So just bear it in mind. I will release the group so that we'll start working as team. We will learn teamwork. Teamwork is very, very important in science. As researchers, we don't work alone, we work as team. So I'll be grouping us, everybody, into two persons per group. Any assignment I give, you do it as a team. As a team. That will be easier because some of us are a bit busy. Unluckily, if your partner is not serious, so everything will be on you. But the reason is, let's see how we can encourage teamwork by ourselves. So thank you so much. I appreciate you for coming around tonight. So I will drop the assignments probably tomorrow. Just try. I will beg you to try. The 2 previous assignments, I have not seen any results. I have not seen anyone. It's all for your own good. I know there is no time. Some of us are already writing exams, and we are marking scripts, we are invigilating and all those stuffs. By the time we get home, we'll be so tired. But practicing will make you efficient. When you are practicing, when you are learning more, it to make you efficient. We are not writing if you have A. We are not writing first position in your certificate, but we just want to, so that when we are giving you the certificate, you know what you that you earned it. You actually earned it, not that you paid for it. You earned it. Make we no be like all those our lecturers where they are junior staff, they write paper, they will tell you put my name. They just want their name to be there and get the approval, so they can use for their appraiser. So that is not what we really want. We want at the end you practice and you have idea of what these things are. So once more, I say thank you for coming around. I wish you all good night. Thank you once more.